Hi, my name is Mr. White, and this is Moss White Science. Today I'm going to be talking about volume as it relates to the graduated cylinder. A couple of key terms to remember as you're going through finding the volume of fluids is one, the increments or the units in which you're measuring the volume, and then also the meniscus. Meniscus, M-E-N-I-S-C-U-S, a very, very key term. First of all, let's go through the increments or the units of measurement. On each graduated cylinder, you might notice that there are large values, and that's to help you figure out what each line is supposed to represent. There are smaller lines in between these larger values, and that's how we try to be as accurate as possible in trying to find the volume. Graduated cylinders are very helpful because they are so accurate as opposed to, say, Erlenmeyer flask or the beaker, because they have these little units of measurements or increments. Now on this graduated cylinder, we're going by the increment or unit of measure of 2 milliliters. How I figure that out is I take a large number that is stated, like 10, and I figure out that there are 5 dashes or little marks from 0 to 10, and so I know right then that I'm talking that each little line is worth 2 milliliters. So that's a little bit into increments or the units. Now I'm going to talk about the meniscus. Now meniscus is a phenomenon that we see when we're measuring fluids in a graduated cylinder. The reason why it happens is because of gravity. Gravity is pulling down on the fluid, and so we see the fluid on the sides raise up just a little bit. So to combat against that and make an accurate measurement, we need to find the top of the water, notice that it has a small little curvature, which is the meniscus, and the rule of thumb is when you see the meniscus, always measure at the very, very bottom of the curvature line. The bottom of that curvature line would be where the top of the water would be. And so we want to measure at the bottom of the meniscus. Why do we use graduated cylinders? Now I've already talked about how accurate they are as opposed to Erlenmeyer flask or beakers, but they really do give us a very precise measurement to the nearest liter, milliliter, depending on which graduated cylinder you're using. Also, it's very beneficial when we're trying to find volume of irregular objects. Say we have a rock that we can't just find the width, base, and height to multiply together. So we would use the volume in the graduated cylinder to find the difference in the volume of that irregular object. Also, graduated cylinders are used for the calculation of density, mass found by a triple beam balance divided by volume. And so volume in a graduated cylinder is usually a really, really good way to find the density of that object. Thank you very much.